Welcome to the Refrigeration Mentor podcast. So glad you're here, always joining, learning, growing. This is what I love about refrigeration is that we continue to learn. There's so much to learn and grow from. And every day I am learning something new. I'm reading more refrigeration books, more on newer technologies, more on natural refrigerants, more on low GWP refrigerants, all these different things that are coming into our industry, which makes it exciting, which makes it fun. And I'm going to bring it back to the basics. I want to dive into some electrical troubleshooting. I really believe that getting better at electrical troubleshooting is going to make your life easier. I'm going to walk through a diagram here. So if you're listening on the podcast, think of any electrical wiring, refrigeration condensing unit diagram. This one here is out of a Keep Right condensing unit. I'm going to walk through this one. This is a 208, 230 single phase 60 hertz unit. That's step number one. What kind of power are you working with? You got to be safe. Number one thing is you need to be safe. I talk about this time and time again. You have to understand how to use your tools, your electrical tools. Where do you put them? Test them first. Safety is our number one priority. If you get hurt, you can't work and make money for your family. You can't do the things that you want. Okay. So understanding right off the bat is what is the voltage you're using? Okay. This is important. A lot of times you get in the manuals, they'll give like tons of different wiring diagrams, just like this one. There was probably 15 different wiring diagrams in this one manual because that one manual speaks for a bunch of different units, different voltages, different phases. And so reading them is very, very important. A lot of times these will be on the panel themselves on different manufacturers' condensing units. I highly recommend just find the manuals. 15 years ago, when I was in the field, Google wasn't what it is today. Search engines weren't what they were doing. Manufacturers' information wasn't what it is today. You couldn't just pick up your phone like today or pick up a computer or make a quick phone call to one of your buddies and they text you the manual. You would have to go to a wholesaler or you would have to go back to the office and they would have to make a few phone calls and they would get like a fax of it, or they would get maybe an email message with a PDF. And I don't even remember honestly getting those back in 2005, 2006. It was happening, but it wasn't what it is today because most manufacturers didn't have digital copies of their manuals on their website. So important thing is to understand, and I said this time and time again, I do a lot of these trainings. When I'm in my supermarket training, CO2 training, the biggest thing is to understand how to read a wiring diagram. The first thing you got to know is that when you're looking at it, the power is off. So any switch that is closed and the contactor coil gets energized, that will open up some relays and contactors. So you want to understand that. You always want to test across loads. That is so, so important. If you test across a switch and there's power to it, you're going to get zero. You check to ground for safety. I watched this video a few weeks ago. A guy off of LinkedIn, he shares a lot of electrical videos because he had an arc flash burn, nearly died, and he puts a lot of great safety electrical. He shows a lot of what not to do, but also there was one on an HVAC where a technician took a video and showed the disconnect was off. So you could just look at it off. Oh, I think the power's off. But he went up to check it with his meter first, which you should always do. It doesn't even matter if it's your foreman, your best friend, or your lover tells you, the power's off. You double check that stuff. You get your meter out there and double check it because there could be power coming from somewhere else. They could have shut off that breaker, but their power could be somewhere else. So this technician was showing that disconnects off. He was still getting 450 or 460 volts across that system when the disconnect was off, the main disconnect. So you want to use ground for safety. And you want to always go across. So this example that we're going to use today is a 208, 230 single phase 60 hertz. So if you're listening try to follow along. If not, jump on and watch the video on YouTube. So the big thing is, the first step is, let's get my little person right here. It's the very top. Electrical coming in. So this is coming from grid power. We got L1 and we got L2. Okay, so on each of those lines, we have approximately, and if it's 230 volts, we'll approximately have 115 and 115, we'll say 120 and 120. So it'll get us really close in that range. So what the first step, and I do this in tons of my trainings, supermarket trainings, like I said, or any really, even my compressor trainings, I talk about when we're doing electrical troubleshooting, you got to get the wiring diagram and have it there. And over time, you get better and better at it, but it doesn't matter the system. The best technicians will get the wiring diagram. Unless you've worked on that system even 1,000 times, you know the wiring diagram inside and out. You can draw the wiring diagram. I still recommend getting it, even if you're experienced. And I talk to experienced technicians. So if you can print this off before you go to that site, just say, whoever you know, this one's a Keep Right. It could be a Ref Plus. It could be a Trent. It could be anybody's condensing unit or whatever electrical you're troubleshooting. It could be an air handler of Carrier or York, whoever it is. You know, and they have a bit more complex wiring diagrams. There's a bit more going on sometimes besides this basic one that we have here. So if we take our meter, and this is one thing that I picked up from a few different people with the last training I did with Rusty Walker, who works with the NSARC. He's their training director, super cool dude, super smart on electrical. I've learned tons and tons from him from electrical. And so what he says, like, Trevor, exactly what I do is I take one of my leads, I put it on voltage, make sure I use a meter. Like I've always used fluke meters. It doesn't matter really the meters that you use, as long as it tests the volts that you're checking. So the fluke, for an example, it will just automatic scale. So it'll put you to the right scale. If it's 230, if it's 575, it's a 460, one. So you just put it on AC voltage, and it'll it'll test and measure the correct voltage. Okay. So what he said is, like, Trevor, I take one of my leads and I just put it on L2. Right. There it is. I'll go and I'll put it in with a alligator clip, or I'll screw it in. I'll get it and I'll place it in there so it stays. So I now can troubleshoot this system with one lead, keeping one hand off. And now I got one. I can go and start troubleshooting everything. But what I get people to do in a lot of my courses is have one of these drawings printed off just like this, because there's not much to this one, and then start writing down the information. And you want to do this on a system that works. And I want you to go in there and test it. You can sit and listen to this. You can sit and watch it until you go out there and test it safely. So what do you mean? How do I test it? So the first thing you do, you want to check, is there power coming into the main? So you can take your one lead and go to, and if it's plugged in there, you go to ground and say, oh, I got 115 volts. Okay, on that one, or 120, whatever it is. So now we know that there's power coming into L2. We put it on L1 now. Now it should say, we'll say for an example, 230 volts. Okay, and from there we can go down to the next one right here, 230 volts. So we're going down to the fuses on the upstream sides of the fuse, 230. Downstream, which is the next stuff. So we check, oh, I got 230 there. Great. And now we keep going through, and you start writing all this down on your electrical wiring diagram. This is so important. There's a power distribution terminal block. You check on the L1 there, should say 230. Or it could be a give or take. It could be 228, 220, depending on that voltage coming in, but I'm just doing an example here. Now I do it on upstream sides of the circuit breaker. So just say even if it's off, if it's open, we should get 230 on the upstream side. And if we went down to the downstream side, what will we get if it's off? They'll probably get 115, right? But if this is closed, you will get your 230 volts. Because remember, we got 115 on this one, and we got 115 on this one. So now upstream of the contactor, so L1 right here. So if we put it on the upstream side, we should get 230. Understanding everything that's on your map. This is your electrical map. It's so important. De-energize, auxiliary 1, we got auxiliary 1, we got auxiliary 2. So auxiliary 1, if we look for it on here, because this is our compressor contactor in real life, compressor contactor auxiliary, right here, auxiliary 1, and what is that connected to? That is connected to the crankcase heater, which is right here. So that crankcase heater is showing us the crankcase heater as well as this receiver heater. So in this, on this system, self-regulated, it says receiver heater, which means I'm assuming there's a thermostat on there. Well, it will, and I'll have to double check that in the manual. So that compressor is off. We have the crankcase heater running on that compressor because we always want that to be running so that we don't get any migration into the oil of that compressor. So the compressor contactor is open at this point. Well, how does it even start up? Well, really, we don't have the evaporator on here, but as we see the L1, L2 coming off the upstream side, we go to our compressor safety circuit. So we got power going up and sending it up this way as we go across and we go up and we go over, and then we got our first fuse. Fuse 1, and it says red RD1. I'm assuming that's red line or red wiring. So we got power going there. And then now we have L2. We'll go across like this and we'll go up. This is our L2, and I'm just showing you as we go around. Just those that are listening, I'm just highlighting it to fuse 2. Okay, so now, well, what do we want to check? So let's check if we got power here. So on the upstream side of the fuse, we should have 230. On the downstream side, we should still have 230 because we're still, that lead is still in L2. So I should get 230 here. If I go down to this terminal block, I should get 230 there. And then if I go on this side, I should have 230 here. So because that crankcase heater at this point, what we're looking at, that should be actually running, that crankcase heater, if we don't have this low pressure switch made. So how would we make that close? So what happens? So not on this drawing, on another page, I'm sure in the manual, it will show that you need a thermostat and a solenoid valve. And actually, when that thermostat makes, so the heat of the box or the heat of the walk-in starts to warm up, it will close that thermostat. When it closes that thermostat, it will send power to usually a normally closed solenoid, opening it up, sending that refrigerant through the liquid, down the liquid line, through the evaporator coil, down to the suction line as a vapor, and then that will start to rise the pressure, which will close this low pressure control, which is very important. So now we have the low pressure control. We got power coming down through here. We got it through the low pressure control, and then it goes to this high pressure encapsulated high pressure switch. It says cut out at 400, cut in at 300. So this could be like a Johnson Control one. You might see a little blue one. There's lots of different brands out there. I think Penn has some. So as we travel through, if that's closed, if we're below 400 PSI, we'll keep going down, and then we go down to terminal 2. Then as we go through terminal 2, we have a discharge thermostat in it. So we would be going through that to terminal 3. And then if there's a time delay on their delay on break, all depends if there's a time delay, because in some systems, like this must be an anti-short cyclone trip, most likely. So if the compressor, if it starts up and it shuts down, it has to wait 2 to 3 minutes. I'll have to double check that in the manual. If power is going through there to terminal 4, then we got a core sense module in here. Well, how does this power up? What do we need? Well, we see off one, there's another line that comes through here that goes to 2, and then we got power coming back from L2 on this side to give it 234 to energize that core sense switch. And if that is made, there's no alarms in that, then we get power to our contactor coil, which would close these, which would start up the compressors, and it would open these two auxiliary switches. The way Rusty said in multiple electrical troubleshooting trainings we did, the way he likes to do it is he likes to break it down in half. So instead of the way I just showed you is going step by step through it, which I highly recommend doing because you're going to be writing what the voltage is the whole time. Because right here you would write, oh, I got 230 here, and then I got 230 here, and I got 230 here. Because if you put it on one, and if it's like this, the circuit's on, you should have from 1 to C over here, which is L2, 230. You put it on 2, you should have 230. Put it on 3, you should have 230. Put it on 4, you should have 230. And put it on 5, terminal block 5, you should have 230 because the contactor coil is a load. And we got 115 on this side, we got 115 on this side, which equals 230 when you energize it. And that's what's going to energize that, have that magnetic field, which will pull in the contacts. Okay, and you need enough voltage. I'm sure in the manual it's going to say like maybe it's 20%. If you have less than 10 or 20%, that it's not enough to pull in the contactor coil. So if you ever heard a contactor coil pulling in and out, in and out, in and out, you might not have enough voltage. There's a voltage drop. There could be a loose wire as well. This stuff here is really, really important to do on systems that are working properly. Because if you came in here and all of a sudden, the way I mentioned that Rusty likes to do it, he would start and he would just have it on L2 and he would just start right at 3, break it up right in the middle of the circuit. And all of a sudden, if he's got 120 volts there, he knows something down upstream is open, right? Because we're not getting that voltage there. So there's something up here that would be open. It's like a switch. When you go across a switch and that switch is closed, just say we go right here on the high pressure switch. You put your probe right there upstream and put it downstream. If that switch has voltage going through it and you put it on one side and the other side, you will get 0 volts. If that switch is open, you will get 230 volts. On this one here, you will get 115 volts because we don't have any power coming through the contactor. So it's so important to make sure that you check this. I apologize. That would be 230. That would be 230 going through that high pressure switch. Okay. Using the meter going across the loads, especially with 230 volt, is so important. I know lots of, like I used to do it. I used to take it and I would go, L1 to ground. Oh, I got 115. I go L1 to ground, 115. I go L2 to ground. Oh, I got 115. I got power everywhere, but nothing's working. Well, it needs 230 volts to work. So usually something is open. So important. I know this was a quick episode talking about electrical troubleshooting. I think the best thing to do is get out there and start having the manuals with you, looking at them at home or in the truck while you're on lunch or coffee break. Take a look at the system that you're working on and then go and get your meter and using the meter in the field safely. And do it like this. Start at the very first. I got 230 coming in. I go down through my disconnect. I go through my fuses. I go through my circuit breaker. I go to my compressor, across my compressor. Okay. Upstream compressor, I got voltage. Downstream, I got compressor voltage. The compressor's running. Great. So that's awesome thing. Now let's go check our safety circuit. Okay. Do I got voltage across all my switches? Okay. Across this switches, 0 volts. Oh, I got voltage there. Across this switch, 0 volts. Great. And what's great about most of the new stuff, it's all terminal blocks. You don't have to pull covers off. Does it take time? Yes. Writing this stuff down take time? Yes. But getting a good understanding on how all that works. And then in the notes, there's so much in the notes and a lot of the electrical wiring diagrams. Like you see, if oil switch not required, wire RD19 to terminal 4. So here's our RD19. wire that to terminal 4 right over here. So you go right here and right here. So we don't have really just taking this out, this core sense. Okay, if you're not using it. This is very, very important to take your time, look at this stuff, because I know I wasn't the greatest at electrical troubleshooting for a long time because I said I was bad at it. I didn't work at it. I didn't try a lot. I avoided a lot of electrical stuff. Like, come on, I did get so many, fix so many things with electrical because refrigeration is like 90% electrical stuff. But I avoided as much as like a fan out. A fan's out. That's basic. Your condenser fan motor, you can see it's out. You can take your compressors, short it. You take your leads, and then you ohm it out. And the power's off, and all the wires off properly, safely, and locked out. And then you check it. Then, okay, it's a grounded, or it's a short, or turn it in short, and then or the motor's short. The thing is, though, one is, why did that happen? So then that's more on the mechanical side. Well, why do we have electrical failure? Well, we got to figure that out, what caused the failure. But on the electrical side, just understanding how to safely use the meter and put it across different circuits. You can troubleshoot stuff so much faster if you understand what you're looking at. And I think that's one of the big things too. I didn't understand what I was looking at because I didn't spend the time. Ask the questions. You find someone who's good at electrical, you just ask the question. Just have a wiring diagram and walk through them like this. What should I have here and here? What should I have there and there? This stuff is really important. And then looking at the notes, finding out what's in those notes. Is it factory wiring? Is it field wiring by you? This is something important. And then getting into the manual, for those that are watching this, I'll pull the manual over because I just pulled this right out of one of the Keep Right manuals. And then here's the evaporator side. Okay, so I couldn't find auxiliary 2 on that last one, but auxiliary 2 is right here. So auxiliary 2 will close when the compressor is off, because normally close, compressor's off, and that will energize the defrost heater contactors. You're doing electric defrost. And then that doesn't come on unless the defrost time clock is enabled or has made in this one here. So you have the standard 1, 2, 3, 4, N, X, and the timer, and the old school time clocks. You should actually be using digital one. Most systems now will have more of the digital ones on there. You'll see like Dixell or Corel or Eliwell, whoever it is, depending on where you're at in the world, they have defrost clocks inside them. Built in. But this is an example where you have to go from one electrical wiring diagram to another one. So this one's a typical evaporator wiring, where now it has the liquid line solenoid and the space thermostat, where you didn't see that on the condensing unit side. So these are some things that are super important. Maybe you're like, well, where's the solenoid? Where's the thermostat? Where's the pump down switch? And you didn't see it on that other page on the condenser, because that was just a condenser wiring. It wasn't the evaporator wiring. And walking through this step by step, you'll see this one's a 3-phase evaporator versus a single phase one. But walking through that stuff as well, understanding this stuff, understanding what you're looking at. And look, this is an 80-page manual. Okay. 80 pages some of it would take me weeks to read 80 pages. Now I could go through this in an hour or two. I could go through this whole, probably 2 hours. I'd go through this whole manual, highlight the stuff that is really important, because there's a lot of repetitive stuff in all the manuals. If you read a bunch of manuals, like talking about evacuation, you should know that. Talking about purging, you should know how to do that. Talking about how to placement of the unit. If you've never done that before, that's something you got to look at. So all this stuff, and there'll be capacities in there, lots of different things in the different manuals. The thing is that you got to look through these manuals, and the more you do it, the easier it's going to get, the better you're going to get, and you're going to feel more confident. And that's the big thing like I'm doing these trainings with all these technicians from everywhere. And most of the time it's like, I want a bit more confidence. And I ask them, if you started reading a bit more manuals, if you started working off the electrical wiring diagrams, if you started reading the sequence of operations, if you started, putting a little bit of effort outside of your work day, do you think your confidence level will go up? They're like, yes, hands down every time. Yes, yes, yes. And this is what I'm talking about. If you want to be better, if you want to be the best at your company, you got to put the work in. I see there's lots of people out there, and I was there at one point where it's like, oh, I'm not, you know what I mean? If I'm not getting paid, I'm not going to training, or I'm not doing this. I was there at that one point, and it's definitely different now. So if you can get in the mindset of continuing to learning, being curious, putting the work in now, I promise you, is going to make you more confident. You'll do less calls to other mechanics, less calls for validation. You will be the person people want to call, and you're going to just fast track yourself. You're going to be solving harder problems than other people. And this is a basic, like I just went through, these are basic troubleshooting skills. And I talked with the team at Keep Right, and they get tens of thousands of calls a year for these basic troubleshooting wiring diagrams. And well, different things as well, but it's a lot of basic refrigeration. If you read these manuals, you probably won't run into as many issues. And I talk to so many troubleshooters. I used to do this type of troubleshooting for when I worked at the manufacturers, taking compressor calls or taking system calls. And a lot of the times is they're not reading the manual. I've said this on the podcast before and many other podcasts, is like people used to call up for support calls and they'll be like, hey, Trevor, I'm running into this issue. And then I just read directly out of the manual. And they're like, Trevor, you're an expert. How do you know all this stuff? I'm like, I just read out of the manual. But over time, I read so many manuals is that I remember the stuff, and then I go actually apply it in the field. What you should be doing too, all of you, go and take a course, learn a little bit about it, learn on your own time, and then go apply it in the field. That's what my courses are all about. If you get into the supermarket academy, I keep saying, you learn how to test this, now go test it in the field. And the same with these electrical wiring diagrams. Get your meter out and safely start to go through. Okay, when you get this defrost time clock, and as you spin, if it's a spin one, so you spin it around, have your meter on there before it switches. So you turn it, and then all of a sudden it clicks, and then all of a sudden that switch will close. Now I should go through a whole session on setting up a defrost clock, but electrical is so important in our industry. If you want to be good and confidence and get confidence, it's reading these wire diagrams, getting into the manuals. And I say it time and time again, I want you to be better. I want you to be better so you have more confidence. And this is why we do all these trainings. We're doing this talk. This is a basic electrical troubleshooting scenario or walkthrough, but I really want you to take the time, and I'd love to hear from you. This is like, send me a message, reach out, hit me up on LinkedIn, Instagram. It doesn't really matter. One of the social media platforms, and say, hey, I've tried this and this works. Because I love that. I get it from the Supermarket Academy. I get it from CO2, Compressor Masterclass, all the time. It's like, man, I went out and tried that stuff you were talking about, and it works. How I set up a VFD, or how I troubleshoot a digital compressor, or whatever it is. And just putting that work in, that little bit of effort. And honestly, if you do 1 hour, say a half an hour a day, every day for 200 days in a year, not even the full year, that's just less. Just more than a half a year. Okay, 200 days, half an hour a day. That's 100 extra hours more that you are going to be better than the next person. Where most technicians maybe put 100 hours of training in every 5 years. I've had lots of people that come into the trainings like, this is the first time I've been at a training, or since apprenticeship school, or first time I've been at a training since school, which was 7 years ago, or 10 years ago, or 15 years ago, or I've never been to school before. And afterwards, they're like, I should have done this before. Because learning is important. Learning is good, and it can be fun. I know it's not always fun, but learning can be fun, and make it fun. And I think the fun part is you go learn something, you go apply it, and then you see the results. So electrical troubleshooting, it's kind of like a 101. Hopefully you took a few things away. I appreciate your time listening here. And if you're listening on the podcast, go and check out the video and walk through it. Take a look at it. Download a manual. Just go to any manufacturer and find a condensing unit manual. They have the electrical wiring diagrams. This one's like I said, this is a Keep Right one. Go to whatever manufacturer you're working on. Get that manual and start learning. Start reading it, understanding. If you don't understand something, call the manufacturer. Say, hey, I haven't been at the site, but I'm walking through this manual and I don't understand exactly what this site. I'm sorry to, you know what I mean? I don't want to take too much of your time. Have your questions laid out. Don't just call with no question. It would be best if you have some voltages, some information, but call them and say, listen, this is my model number. This is my serial number of the unit. I've been running into issues with it, and write all the questions out. This is the voltage I had here. These were the pressures that I had. Have that information when you're talking to them. Or if you see something in the manual that you don't understand, shoot them an email. Say, listen. And if they don't send you an email back, call them up. Ask somebody. Try to get a hold of that so you find the answer out for yourself. This doesn't matter for anybody. Like, it doesn't matter what other people learn or know. I see lots of people like worried about how much this guy knows or how much that person knows or how much she knows. At the end of the day, it's how much do you know? How much do you want to know? Do you want to be the best or do you want to just be average? And it's up to you. It has nothing to do with me or anybody else. Do you want to spend the time to feel confident, crush your day when you're out there on service calls and solve problems other people can't? That's up to you. Once again, thank you for taking the time to listen. If you share this, if you thought you got some value from this electrical talk, share it with someone. I know learning and growing is so important, and this is how this podcast grows: is from you sharing it with others. If you see value in it, I love it. Take a screenshot of it. What you're looking at right now, if it's on Apple or Spotify, and share that. Tag me in it, and I will definitely follow up, comment on it too. So make sure you tag me in those. And I have a free electrical troubleshooting webinar as well on top of this one, where we dive in deeper and talk more about relays and troubleshooting some relays and walking through similar stuff. But if you want to get that, go down to the link or head to my webpage. You'll see it on my webpage, or go to my link tree, go to Instagram, wherever you're at. Get into that electrical webinar. There's lots of great tips and tools in there. As always, looking forward to chatting with you guys again, and let's get the conversation going.